All right, I'm going to go through some of these problems with you. And I'm not going to do them all, but I'll do enough of them so that you can see how to do these problems. So question number 1 and 2, it says a door is made up of 1/2-inch particle board on each surface with a 1-inch extruded polystyrene in between. Use your R value chart on page 2 and 3 to calculate the R value total in each problem. So question 1 says to draw a cross-sectional diagram of the door. So it's a door. When you talk about the cross-sectional diagram, what we're talking about doing is like if you're looking down the edge of the door. So not looking at the surface of the door, but the edge of the door, we would see that there is a 1/2 inch, okay, and this is it says it's a piece of particle board. So I'm going to just abbreviate that with PB. And then it says that there's another 1/2 inch on the other side, 1/2 inch of particle board. And then in between this section right here, in between is a piece of 1-inch extruded polystyrene. Okay, so I'm going to put that, I'll just put that with a different color here. 1-inch extruded polystyrene. Okay, so that's what the door would look like if you're looking down the edge of the door. Okay, the cross-section part of the door. Number 2 says, what's the R value? So we need to look up these values here, and it says to use your R value chart. So there's lots of different R value charts. We look down here, and we've got the R value chart, and we are using a piece of 1-inch polystyrene, and it said we are using 1/2 inch, 2 pieces of 1/2 inch particle board. So we're using the 0.63, actually 2 of them because there's one on the outside and one on the inside, and then the 4R for the polystyrene. So in order to do this, to get the value of the door, we go 0.63 times 2, because there's 2 pieces of the particle board, and then we are going to add, the value of the extruded polystyrene, which is 4. So we go 0.63 times 2, and we are going to add 4 to that. So we get 5.26. 5.26 would be our R value for that one. And then numbers 3 and 4, I'm not going to do it, but let's take a look at it. A student decided to live in his garage with walls of normal 12-inch empty core concrete blocks. He decided to insulate the garage by adding 1 inch of foil-faced poly to the outside of the wall. So again, you're going to draw that that cross section, which just has the block and only one layer of the 1-inch foil. And where are you going to get those numbers from? Let's see. Here's your 1-inch. Here's your 1-inch foil. And masonry systems. Here's your 12-inch normal empty core block. Okay, so that you're just going to add those together to get your value. Let's see. What is the R value of the wall? No. What number 5 and number 6? There's 2 questions here. Number 5 is asking for the R value of the wall at the 2x4 stud. That's this area right here where that little brown or tan thing is a stud. Okay, I'll let you do that one. I'm going to do number 6, where you have what is the R value of the wall cavity. The wall cavity is always talking about where the fiberglass insulation is. There's no wood. Okay, in order to do this, we need to add up the values of all the different layers here. So we've got 5/8 inch drywall, we've got 3.5 inches of fiberglass batting insulation, we've got 1 inches of extruded poly, and wood bevel lap siding. So we have to find the R values for all of those. So we have the 5/8 inch drywall. I actually marked that already as 0.56. 0.5. Let's turn on our pen here. No, I'm doing this one. 0.56. And then we have 3.5 inches of fiberglass bat. That's this right here, 3.142, but that is per inch. So we're going to have to go 3.142 times 3.5. Okay, that's going to give us our value for that. 3.142 times 3.5, because there was 3.5 inches, gives us 10.997. 10.997. Let's move 0.56 over. And what else do we have here? We've got the 1 inch extruded polystyrene and wood bevel lap siding. Here's the 1 inch polystyrene. That's that one right there. And then the wood bevel lap siding is this one right here, 0.8. So you have to add all these up, 0.56, 10.997, 4, and 0.8. So we'll start a new one here, 0.56 plus 10.997 plus 4 plus 0.8, 16.357. Is the R value for this wall right here in this picture at the cavity. Now when you get the value of the R value for this wall down here, okay, all you're going to do is you're going to replace the value of this right here for the fiberglass batting, because that doesn't exist down here in this lower part of the wall, and you're going to replace it with a 2x4 value, which is that value right there. Okay, let's move down. This picture is a thermal or infrared image of a house. Okay, the top picture shows you what a typical house construction looks like. With these are when you're looking at the the stud locations, this is where the pieces of wood are, and then the cavity. This is a great picture to show you this area in between here. This is the wall cavity. Okay, this is where the fiberglass insulation goes, and all these different holes where there's no wood. Okay, the other parts here, these are the stud locations, okay, where the wood exists. Okay, so they have different R values, of course, as you're looking at this, and you can see from this thermal image that in any thermal or infrared image, it tells you that the bright colors and the dark colors are different. Okay, they indicate different things. So wherever you see blue, the cold is represented by blue and green colors. Okay, and that would be areas that are well insulated because the heat is not getting through. This picture is taken from the outside. Okay, where there's warmth that's coming through the wall or through the roof, those would be yellow or red or orange. Okay, and those are areas that are not insulated very well because the heat is escaping through. So you're supposed to write a paragraph explaining why you see the appearance of these different colors in the vertical lines, you know, what's going on with the windows, the roof. Use these vocabulary words that are all listed here. Okay, explain this in your paragraph. Okay, and you've got a number of questions that are dealing with a lot of terms that we used in this. Let's take a look at some of the questions. What would happen to the heat transfer through a material if the thickness was doubled? So we're talking about, you know, we use our equation, power equals excuse me, thermal conductivity times the area times the change in temperature divided by the thickness of the material. So if we double the thickness, what's going to happen is excuse me, that there would be half as much heat transfer that's going on because we're doubling the number here on the bottom that we're dividing by. Okay. Question number 11, what would happen to the heat transfer through a material if the temperature difference was doubled? So in this case, we're doubling the number on the top. Okay. So that means that twice as much heat would move through that material per second. Okay. Numbers 12 and 13. What material is the best insulator in the table? What material would be the best conductor? So we're talking about this table up here. And this is thermal conductivity, and this is your R value. And you'll see of course, the highest R value is going to be the one that's insulating the best, and that prevents heat from transferring through. The K value, or thermal conductivity, is how well does it conduct the energy, the heat. Okay, so we can see the smallest number of conduction is in air, and it's also the largest R value. So that's going to be the one here. Number 12, what material is the best insulator? Is air. What material is the best conductor? Well, that's going to be the one with the highest R value, and that's this one here. It's also going to have, if it's conducting the best, it's going to have the lowest R value. So I might have said the highest R value for this, but this number right here is the K value, thermal conductivity, not the R value. This is the R value. Low R value, high thermal conductivity. So that is diamond. And I'll do another video on the preceding problems, or on the following problems, but I'm going to stop this one so it doesn't get too long.